Welcome guys, welcome to the chat. Recently I had a look at what chatbots, what kind of technology people are using in the chatbot sphere. And you'll actually be interested to find out a lot of it is quite rudimentary. So let's take a look at what current systems are in use at the moment. They use things called regression models, which is just linear regression, where you get a bunch of responses and essentially the model fits using some polynomial function to a certain percentage on each of the response, and then it selects on the highest percentage. Now, obviously with this, you guys can see there's limited responses, and this also takes a lot of work because it requires you hard coding all the responses into your training data. And your question needs to be similar to the input training data, or else you receive some very unexpected behavior with the chatbot. So it's not really that intelligent. So the other kind of models, which are really taking off in the proprietary space of the conversation graphs. Essentially, they have an entry point, a couple parts, and then eventually you reach an exit point where the bot says, "Yeah, thank you, cheers, it was nice to speak to you." It holds a lot of the same flaws as the regression models. Has limited responses. You have to hard code all the responses into your training data, which can be tedious. It's also regression based between the paths, and this one has the added tediousness of having paths that need to be hard-coded, so it's not really the best, but I will mention that conversation graphs are integrated with NLP in the current state-of-the-art technology. The other one is people are using neural networks, which is essentially just an input layer which can take in a word for each node or a sentence for each node, a couple of hidden layers that do some processing that eventually determine an output, which would be one of the responses that are pre-coded into the system. This has similar flaws as regression, although it has a higher fidelity in regression quality, which is one of the bonuses of using neural networks. And you'll find in the model that we're going to discuss, the natural language processor, it uses neural networks at different levels of it. So this here is the creme de la creme when we get to chatbot technology. This saves us a lot of time because essentially we get a knowledge base over here on the top right, which can be literally the website. It can be the websites, it can be a README with like all of the different kind of information that you have about your system or that what you want to speak to people about. And then the NLP takes from the telephony layer, it takes like all of the information from the knowledge base, and it can answer any question that people can feed it you. Literally any question you can give it that's in the knowledge base, it can answer, which is very, very intelligent. And it also builds semantically correct sentences, so you don't have to worry about giving it or hard feeding it responses. And then obviously we have some persistent data storage, which allows for the interaction history to be stored and perhaps any analytics that you'd like to have. This is the main architecture that NLPs have been being built off as of late. It's called the transformer model architecture, and it consists of an encoder, which is the thing that extracts information. This here extracts semantic information about the actual language or the inputs, and this can get fed a full sentence, and it can extract all kinds of information from that. And then there's the decoder, which is the one that actually turns that information into a response. So you have this semantic information that's been encoded, and then now you decode that information into a response. So the way this works is there's a bunch of input embeddings called token, segment, and position, which allow us to get meaning from the sentence. Kind of like this. So you'd have the sentence, and then the token embeddings is a bunch of word pieces that the network has already been trained on. Usually they use the 30K dictionary, which is 30,000 words that have been pre-trained into the system for token embeddings. Then you get the segment embeddings, which embed the segments of the sentence. Perhaps there's two sentences, and then sentence A is, my dog is cute, and sentence B is, he likes playing. So then to get positional information, we need position embeddings, which are in the final embeddings system. And all of these are actually fed into the network via different mathematical functions in order to gain the semantic information of the sentence. And this as you can see, is quite in depth, which allows for some serious information to be extracted from the sentence. The beauty of these is that they're very fast, deeply bidirectional. Because it uses neural networks, it's parallelizable for GPUs, which allows it to be increased in speed. And this actual architecture, this transformer architecture, was originally used for translating between languages, but it's found its way into a lot more clever techniques such as NLP systems. So we've got the encoder side of the network, and if you stack these indefinitely, you get what we call the generative pre-trained transformer, which is, oh, actually, wait, this is the decoder side of the network. If you stack these indefinitely, you actually get GPT, which is what Google's recent artificial intelligence system has been built on. They just stack this 3 times, which is their recent GPT-3, and they get a pretty clever AI bot that can answer stuff. So stacking your decoder side actually increases the ability to make contextual responses. And then stacking the encoder side increases the ability of the network to understand language. So this is where we're actually going to go into one of our initial architectures. It's called the BERT, the bidirectional encoder representation from transformers, which is essentially what we need to make the best chatbot available. We need a really good ability to understand language and then extract information from that sentence that someone feeds, because you never know how people are going to write their sentences. So the problems we need to solve with the chatbots are question answering, sentiment analysis, and even text summarization on our data that we have that we feed contextually into the system. So this all requires language understanding. So you can understand we're gonna look into the architectures like BERT and the various architectures that use similar systems. So BERT is the initial one that we're going to look at, and this one solves the issue of what is language and what is context. And it learns through 2 pre-trained tasks: the masked language model and the next sentence prediction. The masked language model takes a sentence where they mask individual words, and then it has to learn what each of the words are in the mask so it can understand semantic understandings in sentences. So then it will learn quick and it will learn jumps. And that will be part of the pre-training. And then the next sentence prediction receives 2 sentences, and then it needs to learn which sentence follows which sentence, so that we can understand the segment embedding. So these 2 tasks actually solve the position, the token, and the semantic embedding of the sentence, so that we can understand semantics of the sentence a lot better. So to get BERT to perform specific tasks such as QA, we need to fine-tune the training. So this requires actually feeding in a question and then putting an answer in the output and minimizing the cross-entropy error like all neural network trainings. So we take the model, and then we actually have something in here which is a little bit more confusing, because the feed-forward we solve with the neural networks, but this attention heads are what actually gives the NLP its power. What happens is you get the sentence, and each sentence actually gets a vector which represents attention. And the sentence shows the tension of each word on each other word. So obviously the word "the" is pointing to dog. It will have the highest attention on dog. And the word "big" would have the highest attention on dog because it's actually explaining it, and so would "red." And then you see at the bottom here, dog, the entire sentence has some level of attention on dog. So each word has some semantic focus on another word, which is what we get here. This is the attention vector. So these multi-head attentions learn these attention vectors and then feed them forwards into the neural network. And this captures contextual relationships between words, which is exactly what we need. We need it to understand the sentence. Over here in the feed-forward neural network, we have a multi-layer neural network, which has an input layer, hidden layer, and output layer, which gets fed the attention vector as the inputs. And then for the actual learning of the network, we require something called a masked multi-head attention, which is an attention network, but it learns self-attention by only checking the words before the word in question, and everything else is masked, and then must learn what those words are. The example here is just using French, and it's actually translation, because the initial network is designed to do translation. So the architectures we have as I mentioned, were BERT, which is the original NLP architecture for context recognition. And then the new one that's just been developed by some guys in China is XLNet, which is an adaptation to BERT, which uses generalized autoregressive pre-training. Now, I mean, this is some big terms. So let's go basically redefine this. It means denoising the autoencoding based pre-training. This also seems very intense, so let's go into this a little bit deeper. So this is an autoencoder, right? An autoencoder has an encoder and a decoder. It looks kind of similar to what we were just looking at, but there's a bottleneck of information in the center of it. And this extracts semantic information about perhaps an input image, and it reduces it to the lowest dimension. It's kind of like principal component analysis. And it extracts that using the decoder and reconstructs it on the other side, using the principal components which were extracted in the lowest dimension. So it's essentially taking whatever information you feed it, encoding it into the smallest amount of data that can represent it, and then decoding that, which actually ends up extracting all the important information from the data, which is kind of what this our transformer network is doing. And this, just reduces the noise in the system, because as you increase the amount of layers, there tends to amplify noise, which you don't want when you're reconstructing the image, because then you get like these artifacting on the side. Yeah, you can see this image has got a little bit of artifacts on it because of the noise in it. The other network that has just been released, it's state of the art, called ERNIE 2.0, and this one features continual pre-training. So we discussed the pre-training step earlier, which utilizes the masked language model and the next sentence prediction. This one has continual, so every single piece of data that gets fed into it becomes a new training point, and it continues to train, obviously using batch training. And it so far actually outperforms BERT and XLNet, ever so slightly on XLNet, but quite a bit more on BERT. And this continual pre-training is actually being implemented among all the proprietary softwares at the moment, because of the level of intensity of accuracy increases that you get with this kind of technique. So currently, let's just discuss the proprietary chatbots that are in the market at the moment and like what they use. So we've got ChatFuel. ChatFuel is one of the best ones at the market. It's got integration into Dialogflow, which is what Google's been inventing at the moment. Dialogflow is a conversation type graph system, hard-coded though, but it does have some levels of NLP. ChatFuel is the NLP integration. So ChatFuel is your go-to NLP system, and then it integrates into Dialogflow. So one of your parts can actually have little bits of NLP on it, which is why it's quite powerful. Although not recommended, because it requires multiple systems to get this running. We've got Pandora bots, which is a system that supports this thing called artificial intelligence markup language, which is essentially hard-coded systems, but it allows for something a little bit smarter than just dialogue, a little bit smarter than conversation graphs, because it allows for like switch statements, all kinds of like code systems in it. So it handles like coding your system. And then we've got something called Amazon Lex, which is Amazon system that they've put onto the Amazon AWS stack. It's quite powerful, and it uses all of the different code systems, so it's quite robust as well. And it also has a built-in interface with a voice, so that's also quite cool. I mean, Dialogflow uses Google Chat, uses the Google Voice system, but it's not built in. You have to integrate that yourself, which is a bit of a pain. And then we've got Lewis, which is Microsoft's player that they've just introduced into the NLP market. It's called the Language Understanding Intelligence Service. So a little bit more, of a conglomerate competition going on here, where they're trying to be the first to the market. But none of these systems are truly based on NLP. They're combinations of conversation graphs and NLP, or AIML, which is the artificial intelligence markup language. So none of them are truly intelligent yet. So there's that little bit of a space now in the market to create a truly intelligent NLP. So yeah, I hope you guys learned a lot about chatbots today, and yeah, please like and subscribe, because I know this is going on YouTube. Thanks, guys.